Hi, I have a Piaggio engine on the table. It's from a moped like the Vespa Bravo or Ciao, Grillo, Gilera Citta and many others. This version is with a points ignition. It's the most simple you can get, and no kickstart or oil pump function. So it's very basic and easy to work with. And just watch this video. I will show you how I'm restoring it. I will start by removing the ventilation cores for the cooling system. The engine will be used on a friend's Vespa Bravo. The engine that came with it was cracked. The whole corner was missing down here, so I had to find another one. And I think this one is pretty good. So I'll take the best parts from both engines and make a good one out of it. And yes, I did put some lubrication on all the bolts too. They're pretty rusty. Going to remove the small window. That's for adjusting the points. A little rubber cover. And to get the flywheel off, you need a special puller. You can get this one by Bussetti. It's made especially for this job. There's a small thread on the inside, so you can screw this down. And then just fasten this bolt until the flywheel pops up. And then pull it up. And then you can start to remove the coils and the ignition points, the condenser, yes, and the cables. All the connections are made on the ignition points. So there's a cable that goes out to the external ignition coil, and the cable from the condenser with it looks a bit beaten up, and then the cable from the internal ignition coil. Later in this video I'm going to show you how to measure all components to see if they are functioning as they should. A good idea is to change the condenser and the points while you're at it, but if it's a low mileage engine and the parts look good and measure correctly, then you can reuse them. The lower one is for the lights. There are more advanced versions with another coil for a small extra circuit for the flasher, indicator flashers, and on some models a horn, signal horn. Oh, that's broken. This the end of this cable needs to be attached to a small connection that goes to the outside of the casing. That can be soldered on again. And I need to turn over the engine and take this small clip out. Let's see if you can focus on there where my thumb is pointing. Just need to squeeze it with a pair of pliers and then push it out. This is a small spring-loaded washer. It's a bit beveled. It needs to go on top of the what do you call it, a rocker, like to lift the points. On many mopeds it's integrated in the flywheel. On a Piaggio it's a separate part that goes like here. And then here's a key to locate the flywheel onto the crankshaft in a fixed position. And this doesn't hold the flywheel in place. It's just to fix the location until you've tightened it down. It's the taper on the crankshaft that holds the flywheel in place. And there's a rubber grommet here where the cable went out to the external ignition. Just squeeze it a bit and pull it to get it out. And then we've removed all the components from the ignition. And now I'm going to remove the cylinder kit. Which, by the way, doesn't look too good. There are a lot of broken fins down here and the exhaust port looks weird. I don't know what happened there. But I have a few other parts I could use instead. The bolts for the cylinder head are 11 millimeters. Oh, the bolts are not. The bolts are 7 millimeters, but the head, the nuts are 11 millimeters. Then you can pull off the cylinder head. And a few washers. And then the arm for the decompression valve, it sits on top of one of the bolts. To get the piston off, you need to remove the circlip and then just push the wrist pin through the other end. And it can be a bit tight, so maybe you need to support the piston and then press it out with something. I'm just going to remove both sides. It's not necessary, but yeah. And I will just give it a bit of penetrating oil to make it a bit easier for me. Ah, that was easy, no problem. Nice, looks good. It's a needle bearing crank with a 10mm wrist pin. The older ones have a 12mm wrist pin and a bronze bushing in the top of the rod. We're getting close to splitting the engine halves. This is actually, it runs pretty good. This could have been used again, but I need to do some modifications inside the engine, that's why I'm taking it apart. A few tuning steps. Nothing serious or nothing bad, but just removing the restriction in the inlet and opening up a bit more for a bit larger carburetor. The Danish models come with a 7mm carburetor and this restriction. then I'm gonna run with the 10mm and original parts, otherwise exhaust and cylinder kit and so on. And just give a little. It's very slow in the Danish version, and it can barely pull a grown man up a hill. Next step is to remove the nuts on the engine case, and there's a little clip for the earth. Yeah, those are 10mm nuts. Now we're nearly ready to split the engine, but this needs to be done with heat, because if you just try to pry this housing off, it will be very hard, and you'll probably damage the crankshaft. So the trick is to, I will clean it a bit before, because I need to heat it to about 120 or 150 degrees Celsius. And all the oil and dirt, it will just start to evaporate and smell really bad. So I'm going to clean it a little bit. This doesn't need to be beautiful, it just needs to be functional. So a little cleaning. Then I'm going to set up the camera at my vise, where I will heat the engine, and then take off the small cover, take out the crank from the large engine case, and then continue from there. Okay, now we are going to heat the small engine half to remove it, and I've put the engine in my vise and the cylinder studs. Then I have a good a good grip on the engine if I need to pull it off. You need some gloves that can take the heat, thick leather gloves, and what really helps is a temperature infrared gauge, because it's really hard to know how hot it is, because you can't touch it and feel it. And yeah, a simple trick is maybe to spit on it. I've seen people do that, and if it really bubbles and evaporates fast, then you're well beyond 100 degrees, and then it should be good. But you can get simple ones for €10 or something like that. So it's really, if you're doing several engines, it's a really nice tool to have. Also, especially when you need to assemble the engine again. To heat the engine, you can use a propane torch like this. It's really fast, a bit messy, because if there's a rest oil and stuff, it can burn a bit and smoke a lot. You can also use an electric heat gun. This one is capable of 600 degrees Celsius, so that's more than enough. And I like to use that. It takes a bit longer, but it's fine. You can also use a small oven or a heating plate. I have a small oven here in my workshop too, but it's the most time-consuming version that I got. It takes a bit longer to get the heat through all parts, and so I will use the electric one for this video. I'm going to stop recording now and continue when it's close to temperature. Now we're at temperature. It's been 3 or 4 minutes. I will take on my gloves and try to pull off the small engine half. About 130, 140 degrees. And as you can see, it's smoking a bit because I didn't clean it that well. But yeah. Okay, so the whole crank came out of the other side. Normally it would go out of the small side, but that can happen. The question is how I get this out. I need to heat it more, and then I should be able to pull the crank right out. Just gave it a quick minute. Nearly there. Don't ever use force on a crankshaft, because the pin and the button isn't in the center, and if you pull hard or push hard on a crankshaft, you can bend it on the middle, and then it will jump and have lots of vibrations and run really bad. Yeah. There we have it, the crankshaft. Bearings, they are 6202, and this side and the ignition side is with enlarged radial clearance C3. This one is a normal one. Looks really good. It's a moped crank. It has different inlet timings than some other models. This one is the good one, the fastest one. It's used for the 40 to 50 km/h models in other countries, and weirdly on the Danish Bravos too. The Danish Chaos have a Mofa crank. It's for 25 km/h and 30 km/h mopeds. So I'm going to let everything cool down now and give everything a good clean, and remove the rest of the gasket here, and then I'm going to do a little bit of modification to the inlet port. You can see that's what a Danish inlet port looks like, very small, and with a steel restriction on the other side. And yeah, that's the plan. A bit of cleaning, and then I'm going to mount new bearings in the crankshaft and reassemble the engine. Now let's remove the bearings from the crankshaft. I have this tool, it has two sharp jaws, and then you can just tighten it in and it will lift the bearing up. And there's also some accessories with it to mount a bridge over the end of the shaft, then you can pull the whole assembly up. But my bolts aren't long enough to reach up to the long crankshaft on the Ciao. So I will just lift it up until I can get some tire irons beneath, and then I can just pry it up really easy. Oh, normally it's really easy. Just need to tighten the bolts even. Beneath every bearing on both sides there's a small spacer, a washer. I'm just going to save it and reuse it. On the other side it's the same. I'm not going to show you, it's probably a bit boring. I'm just going to make a quick check to see if the crank runs somewhat straight. It's a Piaggio crank is hard to measure because you have only these half webs to measure on, and then on the shaft this outer part is often a bit beat up and scratched or rusty, so you won't get a really good measurement there. So I'm just going to place it where the bearings are going to sit, and then I'm just going to take a look to see if I can see some run out. Or the eye is actually a pretty good measurement instrument for that. It's not a professional measuring, but it's just to see if I can see it has a wobble with the eyes, then no, it's not going to be good. It looks really good. I think it's a good crankshaft. And the original Piaggio cranks are very strong. There are only a few crankshafts that are as high in quality as the originals, like the Machucelli, for example. It's a really good crank. Some of the cheap ones, they have a tendency to break off on the shaft ends. I know the top racing is really known for that. The next would be to mount some bearings, some new ones. The old ones were actually a bit worn, so it's good I opened it. The one I can feel, that's the one from the ignition side. I can feel a small notches or something like that inside. And the one from the short shaft side, it's just noisy. So good thing I took it apart. And now I'm going to put some bearings in the oven, set it to 120 degrees and let them in there for 10 minutes, and then they are ready to just be dropped on. And remember to put the C3 side here and the normal bearing on the short side, and remember the washers. Another thing you want to check is the big end bearing of the rod end. It's normal that you can tilt the rod back and forth, but in and out in the piston direction you should have no play, nothing that you can feel with your hands. You would notice if it had a knock or small, if there was any play, but there's nothing in this one. And it should be run without any noise. If it's dark or blue or violet down here, then it's been hot at some point. Could be because it's run without oil in the petrol or something like that. And it would really have a bad discoloration down here. So, and also rust is a problem. If the engine has been standing for a long time, there will be small rust spots in there. Maybe if you oil it, it could feel fine again, but it won't run many kilometers, and because the rust has made small notches in the bearing surface, and the rollers will roll over them a few times and make really bad marks, and it will really start to deteriorate fast. So just try to spin. It should be totally noiseless, like this one. Can't hear anything. I've had my bearings in my small oven. They are about 120 degrees now. Don't go much higher, or don't go higher at all. You can start to change the hardening of the bearing if you go, let's say 150 or more. So put one of these washers on the crankshaft. Then take the bearing that's with a C3 clearance. That's the right one. It's marked on the bearing, in case you're wondering. And then just drop it. The bearing has to fall all the way down, make sure of that. And this one is, can maybe put a little bit of weight on it just to be sure, but don't bang on it with a pipe or anything unless you have it supported in between the crankshaft webs. Because if you just bang on it right now, you can bend the crankshaft on the pin. So I'm going to let that cool a bit and reheat the oven a bit if it gets too cold. Then I'm going to turn it over and do the same with the other bearing. I've been heating the engine for a few minutes. It's been cleaned. I've made my modifications to the inlet port, and the crankshaft is ready with new bearings. Let's try if it will fit. Remember to get it high up to have enough space for the long shaft. That's it. And then just let it cool off, and then prepare the gasket, heat the small housing up, and then close it. I'll be back. I kind of forgot to record the mounting of the small housing. I was heating it, and then I wanted to make a short break, and I forgot to film again. But what I did is heat it up to 150 degrees, put it on quickly, have a hammer ready if it sticks a little bit on the location bushing, or a bit on the bearing. It's not good to hit on a bearing, but with a rubber hammer you can just give it a small dab. But this one went right on. Turn it over quickly and have gloves on because it's very hot. Put the bolts in, tighten it down, and then let it cool. If you tighten every bolt down and remember the clip for the earth, then just let it cool down and check if it runs freely. What happens often is because of the cooling down, it kind of squeezes the bearing a bit, or the compression of the gasket, or both. So what you can do if it doesn't really run that freely like a new bearing would, and hold the engine and give it a few dabs on the small engine housing. That normally releases the stress, and then it runs really good, like here. It's totally free. So next up is that's to make this test. It's important not to have the oil seal in from the start. So I'm doing this later. It makes it a bit harder, but if you use a punch and slowly go around until it's flush with the housing, you're good. I'll just lubricate it a bit, outside and inside. Never mount a rubber seal dry. You can rip the seal. Now you will see a new seal really has a lot of friction, so it won't run as nice as before. That's why I leave it out to start with. And also, if you're heating the case, it's not nice to heat so much on the seal. Next up will be the ignition. Let's measure some ignition parts and talk about the function. Here we have everything. We have the lighting coil, the ignition coil, the internal one. Some call it the feeder or primary ignition coil. I think that's a good. Let's call it primary ignition coil. Then we have the breaker points and the condenser and the external coil. This one is a bit fucked up, but it works. You need a multimeter that can read resistance in ohm. That's the most basic function you need. If you want to test the condenser, you need a function to measure capacity in infrared. This one can do it. I also have a LCR meter, a cheap one. This one is especially good for low ohm, low resistance. This one it gets a bit wonky beneath 1 ohm. But this one gives very good readings. So it's especially good for these coils, the light and the ignition coil, and the primary side on the external ignition coil, secondary ignition coil, because they are all beneath 1 ohm. And the breaker points, they just need to make contact and don't make contact. It has to there has to be no contact at all if they open. Sometimes when they break, it's the isolator between the two parts that cracks, and moisture can make a short between the outer and inner part here. Then your moped won't run. So let's start by measuring the internal or the primary ignition coil. You have to measure between the end of the, actually between the coil, both ends of the coil. One of the ends is connected to the earth or the core, and the other one is connected to the breaker points. So measure between those two. If you have a manual voltmeter or measuring device, you have to set it for the 20 ohm range, like that. This one is automatic with auto range, so it will figure it out itself. On these Piaggio coils you have a loose ground connection, so you can connect it to, you don't need to connect it to the core. As you can see, it's about an ohm, and then it falls. I would probably get a better reading with my other meter, but let's just take this. So I would say if you're between a half and 1 ohm or 1 point something, it will be fine. It can still be broken if there's some corrosion in the wires or a loose connection or something like that. But with this measurement, you have a pretty good idea where you are. So this one is fine. Also look for cracks in the insulation, and the coil is painted with a thin coat of clear varnish, but here and there's a bit of extra protection. Okay, next one, the lighting coil. And this reads very low. That's normal. That's how it is from the factory. It nearly looks like a short, but it's also thick wire and not many windings. Again, we would get a better reading with this LCR meter, but yeah, this will do. Now let's take the secondary ignition coil. That's what I talked about. It's a bit fucked up. Normally there's a small ground connection here and someone put a wire on it because it broke. So I'm just going to measure from this clip, would normally be your ground, and the core or the small wire that comes out of the side. And then you measure to this clip. That's the input from the primary coil. Measure between those two, and that again is about 1 ohm. A bit below, a bit above, you get the idea. Then you move to the connection to the spark plug wire, the screw inside here. And there you will have, normally it's about 6,000 ohm or 6 kilo ohm or below, maybe 5 to 6 kilo ohm. That's a good reading. This one is 5.77, so 5,770 ohm. And that's great. Again, could be broken if it heats up and a connection gets loose inside. That's what happens typically on ignition coils. But this one, I think it's fine. Let's go over to the measurement of the capacitor. You need to go over to the capacity mode. That looks like this on my meter. Some mopeds have about 200, let's see, I think it's picofarad. Is it pico? Nano? It's nano. Piaggios, they can be very high. I've seen some 350 above that, and they work great. This one is about 280, that's a very normal reading. I would say everything between 2 and 400 is a great reading. And then the last measurement, just to see if there's a short in the ignition points. Go back to resistance reading, maybe put some sound on it. That's not. Where is it? Yeah. Connect one end to the part that's connected to earth, or ground, the engine case, and the other one to the end where the cable comes out, or the cable connects to the breaker points. Open the breaker points and see if the connection is lost. And there's no connection at all. Great. Now I'm going to mount the ignition. I've made a new cable for the external ignition coil. There's a small ring terminal on it. The rubber grommet and some protection. It's important to get all the cables in the right place. Don't want to have them in the rotating flywheel or the primary ignition coil. It needs to be routed below the breaker points. There's a small gap. When you tighten the coils, press them in against the crankshaft to be sure that you have enough clearance out to the flywheel. You can, if you want, take a feeler gauge and the flywheel is mounted, rotate the window around and then press a thin feeler gauge between, loosen them and adjust it very tight, then you will get the best performance of your ignition and your lighting coil. I think the recommended space is 0.3 or 0.4 millimeter. The ignition coil should have been the cable from the ignition coil should have been routed below the ignition coil. On the condenser you have a small strip of felt. It needs either give it a few drops of oil or a bit of grease. The short side goes down and then the cable is routed just below the lighting coil. And I need to loosen the lighting coil again. Forgot that cable too. I nearly forgot the rocker for the breaker points. Put the split, I don't know what it's called, back in the crankshaft. Ignition key I think, or keyway or something like that. Then put the breaker points rocker back in place. You can't turn it the wrong way, it's symmetrical. And then remember the small spring-loaded washer. Now you need to connect these 3 cables from the capacitor, from the cable out to the external ignition coil and the cable from the internal ignition coil. Make sure everything is tidy and doesn't come in contact with the flywheel or other moving parts, because you will short the circuit and you will lose your spark. Now you can set the points. Pull the rod all the way up, then you will have approximately the position where the piston is in the top dead center. Use a feeler gauge, and my recommendation is to set it to 0.4 millimeters. We will check the timing later. So if you have a micrometer screw or something to measure you can also use a degree wheel to find the timing. Then you can adjust it really precise just by the gap in the points. And if you don't have that, then just adjust them to 0.4. What you do is, if the piston is atop that center, you will have a small gap in your breaker points. I don't know if you can see it. That gap has to be 0.4 millimeters. So it just needs to slide with a light contact. Don't push it in, because you will just expand the spring. There's this small adjustment hole in the top. Right there. Loosen the screw a bit, and then you can put the screwdriver in and adjust the gap. Now, time to put the flywheel on. Now you just need to mount the rubber cover. There's a small window where you can adjust the ignition points. And then what I like to do is take the clutch and just tighten it down so that the flywheel gets pressed down on the table, so it won't move. If you want to test your ignition before you mount the engine in the frame, just take the coil and mount it to the engine case, and then take the wire from the internal ignition coil and hook it up to the small connection where you normally would connect it. Take a piece of ignition wire and hold it in place 5 to 10 millimeters from the engine case, and then turn the engine around and look for a spark. It should do at least 5 millimeters spark, and easily 10. If it's a really good ignition, it should be able to jump 10 millimeters. It's time to mount the cylinder. The gasket that came with my kit was really bad. It didn't fit on the cylinder skirts, and the ports were too small. So I cut a new one from a thin paper gasket. Now to get the piston inside the cylinder, you need to find the locating grooves. There's a small pin, and that's where the opening of the piston rings needs to be, and you need to align both. And then look for an arrow. It needs to point to the exhaust port. Then just slide it on the engine. Remember to mount a fix ring on both sides, a circlip, and in this case with the sharp side up. If you feel on the edge of the circlip, one side is a bit rounded and the other is sharp. Make sure the opening points towards the engine block. Now you can slide the cylinder in to the engine block. Time to mount the cylinder head. I've mounted the decompression valve cleaned everything. And I'm not going to use a head gasket. That's how they came from the factory. But you can add one if you're nervous that it's going to leak. Remember the small clip for the decompression cable. I'm torquing it down to 12 Newton meter. A new spark plug from NGK. I'm using a B5HS. That's the normal heat range for a stock or near original Piaggio engine. And the capping it's always good, but if you want to check it, let's say 0.5 to 6 millimeter. That's it. The engine is done. It's not beautiful to look at. A lot of old corrosion and rust, but it should work really well. It has a good compression, and I tried to blow in the inlet, and there's no air leaking past the crankshaft, so that's really good. The ignition works. Yeah, I think my friend will be very happy to have this engine on his Vespa Bravo. That's it. That's the end of the video. I hope you enjoyed it, and thanks for watching.